Assalamualaikum. I am Engineer 1 and my name is NAZEERA binti RADUAN. I would like to explain about abstract of this project. A boost converter was designed to produce an output voltage higher or greater than the input voltage. The result when the switch in a circuit of boost converter opens, the output stage receives energy from the input and the inductor. Hence, the output voltage is high. This assignment aims to create a boost converter that operates in continuous current mode CCM with a switching frequency 20 kHz that outputs a voltage VO of 18 volt from a variable DC source Vs from 12 volt. The converter is needed to satisfy output power PO from 10 watt to 20 watt. The maximum peak-to-peak ripple voltage of 100 mV is calculated after obtaining the value of the duty cycle. Minimum value of the inductance was used to ensure CCM of the current overall condition. The voltage output of a boost converter is greater than the input voltage. The design of the converter is obtained with the specification given. The simulation of the graph and the block diagram will be shown in MATLAB software. Results from the simulation were obtained by analyzing the component using multisim. Next, I will explain about background study for this project. DC to DC conversion power supply is converting the unregulated DC input to a controlled DC output with the desired voltage level. One of the DC to DC conversion of power supply is boost converter. In this paper, some parameters were calculated to design the boost converter circuit and the simulation result of the boost converter circuit are provided. The value needed to calculate is the range of duty ratio D, capacitor value that result in the maximum peak-to-peak ripple voltage of 100 mV and the minimum value of the inductance to ensure CCM of the current overall condition. Next, I will move on to the problem statement of this project. The issue that needed to be focused such as rapid testing, nonlinearity, and calculation problem have to be solved repeatedly until the work it reaches a tolerable result. The boost converter circuit was simulated using multisim software. Therefore, by using MATLAB software, it helps to analyze the output voltage transient response such as rise time, overshoot, and settling time. The objective of this project are to study boost converter topologies and analyze stability for each equivalent circuit denoted as mode 1 and mode 2. Second, to derive the state space model and state space average model of the converter. And lastly, to study the difference of open loop and closed loop in the system of boost converter. Thank you, and I will pass for the next presenter.
Thank you, Engineer NAZEERA. I'm Engineer Hakim. Will explain about methodology. Firstly, DC-DC converter topology for the boost. The well-known circuit for the non-isolated converter are the boost converter. The duty cycle value was used to calculate capacitance value that result in the maximum peak-to-peak ripple voltage of the 100 mV. Minimum value of the inductor was calculated to ensure continuous current mode over all conditions. So the boost converter was designed using the given requirement value. So the value of Vout is 18 volt, input voltage of nominal 12 volt, output power of 10 watt, Vout ripple of 100 mV maximum, current ripple of 800 mA peak to peak, and it's operate in continuous current mode. So in mode 1, which is MOSFET was on, the component of MOSFET in mode 1 is closed and the current will flow from the power source. So the red line means the flow of the current. This will make voltage dropping from the capacitor to the output. The capacitor will only make the voltage drop at the output load voltage as the component diode block the passive wave back to the power source. In mode 2, which is MOSFET was off, the component of MOSFET in mode 2 is open and make an open circuit near the power source as shown in figure. The current will flow from the power source to the diode, capacitor and load resistor. So the red line means the flow of the current. In this situation, the capacitor was in charge and the voltage will be stored to be released in the next state, in mode 1, to load resistor as to make voltage step up system as a boost converter. Operational of boost converter circuit. When MOSFET was closed in mode 1, the inductor will start to store voltage or energy. When MOSFET is open in mode 2, the voltage from battery and the inductor will use to charge the capacitor. With the MOSFET keep on switching between mode 1 and mode 2, the higher charge voltage on the capacitor from the battery source will increasing continuously as each cycle running. For each cycle, inductor transfer energy to the capacitor. The capacitor voltage will increase until it reach the state of equilibrium. The function of the diode in boost converter is to block the capacitor from being discharged back to the battery source to achieve equilibrium so that the capacitor can be only sending the current and voltage to the load voltage. In addition, the sum voltage from the battery and also inductor is greater than the source battery from the higher output. The current will be decreased, which is the power is remain. We assume it's 100 efficiency. There is also very little current loss when the cycle is carrying. The current loss to surrounding and source when the gate of the MOSFET is closed and open continuously. As the frequency increasing, the voltage charge across inductor and capacitor will increase. So in precaution, when we are handling the boost converter, we should be very alert to the current because high current may be very damaged to the engineer. So next, state space model and equation. Averaging method. To apply averaging method for modeling, mode 1 and mode 2 model equation are modeled as follows.
Sir, I'm engineer Lee Wonjet, so I'm presenting the part of the mathematical calculations and also for the simulation by using multisim. So, for the parameter requirements for our assignments, for our project, we given the Vin, which Vs equal to 12 volt and Vout supposed to be 18 volt. And in this assignment, we are using a 10 watt, okay, 10 watt of power, and also a frequency with 20 kilohertz. Okay, and the ratio is between 0.5%. So in order to calculate the duty cycle, we're using this kind of formula, and the answer we get is 1 over 3 or 0.33. And to calculating the current flow, the answer we get is around 0.556 ampere. And then to find the correct parameter to fulfill our requirements, so the resistor that we calculated out was using 32.4 ohms. And for the inductor, they have a range which inductor minimum value and also maximum value. It's about 0.17 millihenry or 0.22 millihenry. And the capacitance capacitive value using is 0.101 farad.
My name is Muhammad Danish AQRABIN AZHAR. Today I will present to you about mode 1 and mode 2 state space model. This is the circuit diagram for mode 1 condition. The state for mode 1 state space can be written as 1x2 equal to 0, 0, 0, negative 1 over RC, x1, x2 plus 1 over L, 0 V in. X equal to A1, X plus B1U. X1, X2 equal to 0, 0, 0, negative 3002.35. 0.833 times by 0.833 18 plus 4464.2860 times by 12. Next is the mode 2 state space model. This is the diagram for mode 2. State for mode 2 state space can be written as x1, x2 equal to 0, 1 over C, negative 1L over L, negative 1 over RC, x times by x1, x2 plus 1 over L, 0, V in. X equal to A2, X plus B2U. Then x1, x2 equal, by using this equation, we calculate for the diagram, we get x1 over x2, 0, negative 4464.286, 97276.265, negative 3002.35 times by 0.83318 plus 4464.286 0 times by 12. Next is the average state space model. The averaging method combines the state space model of the two modes to obtain x equal to a bar x plus b bar u. A bar equal to a1d plus a2 times by 1 minus d times by b bar equal to b1 d b2 plus 1 minus d. x1 we can use the equation 0 x1 x2 0 negative 1 minus d over L 1 over d 1 minus d over C and negative 1 over RC times by x1 x2 plus 1 over L 0 V in. Then we can calculate for the both, for the average x1 x2 we get 0 negative 2991.071, then 6517.5.097, negative 3002.35 plus 4464.286 0 times by 12.
Hello, my name is INTAN ZURATIKAH binti ISMAIL. I am the project leader of this group. Next, I will explain about the Simulink and decoding to stimulate boost converter model. So, this is our Simulink of our circuit. In the Simulink, we use SimScape electrical add-on to construct the circuit. The component that we use is inductor, resistor, capacitor, diode, MOSFET, DC voltage source. And the tools that we use is current measurement, voltage measurement, the display, and the scope. We use the scope to get the graph. So, before that, we are given input voltage which is 12 volt and the output voltage which is 18 volt. So, before I do this Simulink, I do the calculation that will explain by my group mates. So, this is the calculation. From the calculation, we can get the duty cycle which is 0.33, resistor which is 32.4 ohm, the inductor which is 2.2386, power of negative 4, and the capacitor which is 1.0185 power of negative 4 farad. And frequency that we use for our circuit is 20 kHz. In this Simulink, we insert the value of the inductor, the value of capacitor, and the value of the resistor. And we also need to insert the value of the input voltage, which is 12 volt. Next, at the bus generator, we need to insert the period, which is frequency we use is 20 kHz. So we need in period, so 1 over 20 kHz. And the duty cycle that we get from the calculation is 0.33. But we need in percent, so 0.33 multiplied by 100%. Next, when we click run, we get the output voltage which is 17.92 volt. We're supposed to get 18 volt, but 70.92 volt is close to the 18 volt. Next, the output voltage response. So this is the graph for the output voltage. And from the measurement, we can know that we get 70.92 volt for the output voltage. Next, the coding to get the graph of step response curve. So this is the step response curve. So from the step response curve, we can analyze setting time, which is 405 seconds, rise time, which is 125 seconds, and overshoot, which is 10.30%. That's all. Thank you.
So this is our circuit simulations. So we're representing using multisim. So by using multisim, we are using here all the requirement using simple boost converter with 12 volt, and also this side is this is the MOSFETs and the inputs with 33.33% of duty cycle, same as the previous project. So the parameter was key in in multisim, and I will start my transience analysis. I'll set in here, and this is the graph that we get. Okay, just simply shows you. So for initial, there's supposed to be 12 volt, but there's something where difference value which drop something 0.5, around 0.5 volt. So in the initial time, the voltage was charged more than the requirement that we want, which is 18 volt, and then it suddenly drops by the time and going up and down, and the difference between the maximum and minimum value will be decreases following by the time. So we are wasting of time and using a simple regarding the rise time. So from this circuit, rise time is around 10% to 90%. Then that we calculated out, the rise time is between here. I will show you in our report between the rise time. Okay, this is the rise time, and the difference between it we have calculated, and is around 336 microsecond or 33 millisecond. Okay, and for the overshoots, which means overshoots is in between here, the time for it to becoming the largest value. The overshoot shows you here. Okay, this is the overshoots. So overshoots mean the supposed value that we wanted, but for initial time it go up very high. Okay, and the time for it go up and down to the value that we want is around 2 milliseconds, and our report shows that the time is around 1.638 milliseconds, and the maximum value that we get for the initial time is around 22.22 volt here. Okay, while for the setting time is here. For the whole process from the initial to when it's become constant or stable state, okay, the requirement time it needs is around 4.87 milliseconds. And then I'm going to show you around the ripple voltage. Well, ripple voltage mean for this circuit, when it's in a stable state after it, there will be a gap between all the values. See, this is means by ripple voltage. So the value supposed we get is around 17.5, but there is also up and down, which means maximum and minimum value, because we are using a DC booster converter with the presence of MOSFET circuit or MOSFET equipment. MOSFET is turned on and off periodically. So this means This up and down graph shows the mole facts volts. Okay. To make it constant, the mole facts will touch the capacitor and the inductor. So every component in here will take in their representative. So finally, settling time and also for the transience analysis circuit, the ripple voltage in stable state we calculated by the deduction with the maximum to the minimum value, and we get was around 100 millivolt. So thank you for my presentation.
For the discussion, the desired values of the component have been calculated to design a DC to DC boost converter circuit. There are only one set of calculated parameters for inductance, which is L, and capacitance, which is C. The minimum input voltage and power from the range is used, which 12 volt and 10 watt respectively. The L and C values for each set are shown in the calculation segment. Before the circuit is simulated, the value of the parameters need to be chosen. The inductance have been chosen is from set 1, which is 0.22 millihenry. This is because the inductance from set 1 is the highest value among the sets in order to get a small ripple current value in CCM. Same goes to the capacitance value 0.102 millifarad is chosen from set 2 due to its greatest value among the others to got the smallest output ripple voltage. Switching frequency, there are a few values that have been tried, but the final value that meets all the specification is 20 kHz. Next, for the conclusion, we can conclude that the boost converter is a DC to DC power converter that steps up voltage while stepping down the current from its input, which is the supply, to its output, which is the load. For this operation, we use MATLAB simulation to find output voltage transient response, which is the time, overshoot, and settling time. Next, for the Gantt chart, consists of 9 tasks, which is project briefing and select project title, research and brainstorming, chapter 1, which is introduction, chapter 2, which is project methodology, chapter 3, which is result and discussion, chapter 4, which is conclusion. Next, we write the final report and check for the finalized report. For the project briefing and select project title, we brainstorm the idea from 5th of November until the 12th of November. Next, for research and brainstorming, uh, the idea more is from the 8th of November until the 19th of November. Next, for the chapter 1 introduction, we do it on 50th of November until the 19th of November. Next, the chapter 2, which is project methodology, we do it from 50th of November until the 26th of November. Next, for the chapter 3, we do it from 22nd of November until the until 17th December. Next, for the conclusion part, which is chapter 4, we make it from 22nd of November until the 3rd of December. Next, for the final report, which is we compile all the parts, it's from the
26th of December until 7th of January. Next, we finalize the report, which is we checks all the mistakes or misspell. We do it on 1st of January until the 60th of January. Thank you. That's all.